Let's define the domain and the range. Do notice that in this case we have a couple of examples or graphs that we can try with this. And let's build a quick table first. And let's remember that open dots, and a graph we use open dots to denote that the value will not be accepted as a solution. So value is not accepted if it's an open dot. And we have two forms of showing this or describing our domain and range. We have inequality notation and interval notation. Do remember, for inequality notations, we use open dots, or we can use greater than or less than inequality signs. Or interval notations, we can use parentheses. Whether it's in left or right side parentheses will depend on whether it's your high or low value that you're talking about. Okay, so closed dots. Closed dots. On graphs, we use closed dots to denote that the value is accepted as a solution. So it can or is definitely a solution when it's a closed dot. And for closed dots, we use inequality such as greater than or equal to, or less than and or equal to. For interval notation format, we use brackets. Whether it's left side bracket or right side bracket, once again depends on the values that we have. Okay, so let's remember to label our axis, and we'll start with a linear equation or linear graph. X and Y axis labels. And for reference, let me say just randomly that the first side or the left side of our linear equation has an open dot. The right side of a linear equation, I'll build it as a closed dot. So open dot, there is an acceptable solution. Pardon me, there is not an acceptable solution, right? Closed dot, it is an acceptable solution. Okay, so linear graph, looking at the linear graph. Domain, x value, remember, x represents the domain. It tells us what x values are acceptable as solutions when we talk about the domain. And range, what y values are not accepted as a solution. So we typically start by putting an x and a y in the middle, or wherever we're going to answer, somewhere in the middle. Okay, low boundary and high boundary is what we typically look for on domain and range. So what is the low boundary for the domain? Low boundary for the domain. Oh, there we go. Dashed line on the left side of our linear equation roughly gives us what the domain lower boundary is. It looks like it's -2. Yep, -2 is the lower boundary. And higher boundary, going for the right side, dashed line looks like about, kind of hard to read, but we can see that it's 4. Agreed? So higher value, 4. So we put an x in the middle. On the left side, we put the lower boundary. On the right side, we put the higher boundary. Okay, so on the left side, we have an open dot. That means -2 is not acceptable as a solution. So we put a less than inequality sign because it's the lower boundary. So with x in the middle, we have a less than or sign between the -2 and the x. So far we have -2 is less than x. And now between the x and the 4, it's a closed dot, so we have an equal sign added to that. So x is less than or equal to 4. And therefore we read this for our domain. -2 is less than or equal to x, which is less than or equal to 4. Or in short version, the x values that are acceptable are between -2 and 4, with 2 not as an acceptable solution. Range, the y values. Okay, what is our lower boundary? The lowest value. No, let's take a look at the dashed line there at the lower left side of our linear equation. Roughly seems to be about -4. Yep. Higher boundary. What is the y value? Higher value. Okay, it looks to be about 2. According to our dashed line there for reference. So higher value, 2. Lower value, -4. And once again, lower value is an open dot, so we have a less than inequality sign. Higher boundary, we have a 2, which is a closed dot on it. Means it has an equal sign added to that, so less than or equal to 2. So we read this -4 is less than y, which is less than or equal to 2. Okay, so let's try this in interval notation format. Domain, we say lower boundary is -2, higher boundary is 4. Lower boundary always goes on the left side, higher boundary always goes on the right side, and a comma in the middle. Now to define whether we need a parentheses or bracket. So let's see, -2 we said is not an acceptable solution because it has an open dot. So we put a parentheses. 4 on the other hand is an acceptable solution. That's the right side. So we put a bracket because it's a closed dot. Range. Lower boundary, -4. Higher boundary, 2. Okay, -4 is it has an open dot, so therefore it takes a parentheses. The right side, the 2, has a closed dot, so it takes a bracket. It is an acceptable solution. Okay, how about if we try the parabola there? I'll say on the right side of this parabola we have a closed dot, and on the, left side of our parabola has a closed dot, and right side has an open dot. Okay, let's remember to label our x and y axis. And once again, looking at the partial parabola graph. Domain and range. So once again, remember that domain always refers to the x value, and the range always refers to the y value. Okay, what is our lower boundary? So lower boundary for x seems to be -2. Yep. Higher boundary for our domain seems to be 4. And notice at the left boundary, the lower boundary, the -2, we have a closed dot, so therefore we need a less than or equal to inequality sign. Right boundary, open dot, less than inequality. Range, look at the bottom. The lowest value is not necessarily the closed dot. It goes below it. So unless I tell you this, you won't be able to figure it out. So let me tell you. This graph actually touches and barely touches the x-axis. So it touches the x-axis. That means x is the intersection point, or we can say y is equal to 0 at that particular point, right? So the range, 0 is the lowest value. And the highest value for this case is roughly, we can see 16. So 16 is the highest value. So since 0 is an acceptable solution because it touches the x-axis, we put a less than or equal to sign. 16, let's see, has an open dot, so therefore it takes a less than inequality sign. It's not an acceptable solution, so less than will do. And once again, interval notation, domain format, the lower boundary, -2, higher boundary, 4. Bracket on the left side because it's less than or equal to, or it has a closed dot. On the right side, it has an open dot, so parentheses. The range for our partial parabola graph. Once again, the lowest value that we have is a 0. Highest value that we have is 16 with a comma in the middle. Do remember, this is not a coordinate. This tells us the lowest and highest value for either the domain or the range. In this case, the range. So in this case, 0 is an acceptable solution because I said it crosses or barely touches, I should say, the x-axis. So it takes a bracket. 16 has an open dot. It's not an acceptable solution. So therefore, we have a parentheses.